Okay, so this is Math 005, Lesson 2, Part 7, and we're going to work on a couple of problems from the in-class worksheet 1.4. So in this case, we're looking to collect like terms, and you need to, like I said before, you need to be very, very clear about which variables and what exponents are on those variables. This one looks like you could add them all together, but I want to point out this one has an exponent of 2 on the b, and these both have an exponent of 1 on the b. So we cannot combine that negative ab squared with the others. Now, can we collect those other two? We'll take a look. So I've got an a squared b, or b to the first, and I've got an a squared b to the first. Those two I actually can combine. Now I'm going to take the little baby steps along the way so that everybody can see exactly what's happening. You could probably just kind of jump to the next step beyond this, but I want to, like I say, take all the little baby steps along the way so that it's real clear what's happening. So 5a squared b minus, I'm keeping my negative sign here with this, minus a 7a squared b. All right, so this one's taken care of and this one is taken care of. And now I'm going to say subtract my a b squared. All right, and again, I cannot combine this with these other two, but I've still got to keep it in the expression. All right, so here I've got my 5 and I've got a negative 7. That means I'm going to wind up with a negative 2a squared b, right, since we know these are the same variables and exponents. And then I'm going to have a negative ab squared. Now, this is as good as it's going to get unless we start factoring things out. I'm not asked to do that, so I'm not going to do that. All right? So this is as good as that particular problem or that expression is going to get. So let's scroll down a little bit. I want to go ahead and do this one. I've got some distribution happening. I'm going to have some collection that I've got to do. Let's go ahead and get that started. So my 3 times 2x is going to give me a 6x. My 3 times a negative 1 is going to give me a negative 3. Negative 4 times x is going to give me a negative 4x. And my negative 4 times positive 2 is going to give me a negative 8. Now I've got a negative 5 times 3x. That's going to get me a negative 15x. Right? We're doing this one step at a time. And then I've got my negative 5. I've still got to multiply this plus 4 to get me a positive or negative 20. All right, and keep in mind, most people will do just fine multiplying that first one, but as soon as you get a second or third part in these parentheses, a lot of times people will start making mistakes and they'll forget to do this. And I'm no exception. On occasion, I have done that. I'm human just like everybody else, but hopefully, by my pointing it out, hopefully people will make that mistake a little less often. All right, so now I'm going to go ahead and I'm going to collect what I can. I've got a 6x, and I have a negative 4x, and I have a negative 15x. All right, I've got all of my x's. I've taken care of this x, and this x, and this x. Those are done. I've taken care of them. They're rewritten, and I can go ahead from there. Now I'm going to have my negative 3 minus 8 minus 20. And now it's a matter of just collecting, right? Here I have 6x minus 4x. That's going to leave me a positive 2x. And now I'm subtracting 15x from that. That's going to give me a negative 13x. Right? These all combine to give me a negative 13x. Now I'm going to have a negative 3 and a negative 8. That's going to give me a negative 11 minus another 20. So I'm going to have a negative 31. All right. And that's as far as we can go with that one. Let's take a look at our next bit of information. I want to go ahead Here I'm being asked to evaluate, and what evaluate means is I'm actually going to do some mathematics. I'm going to do some arithmetic. Here they're telling me, here's this equation, or here's this expression. They have x's, they have x squareds, they have a y cubed, all of that stuff is in there, right? They then tell me what my x value is, and they tell me what my y value is. I'm going to replace all of those x's with a -1, and I'm going to replace all of those y's with a -3. So I'm literally going to just rewrite this, plugging everything in. I am not going to try and do any of the arithmetic on this first pass. All right, I want to make sure I'm just plugging all those points in, or all those values into the right place. So I'm going to have -1 in place of this x, and that's squared. And then I'm going to have y cubed. Well, my y is a -3. And I'm cubing that, minus 2 times -1, right? Because this is an x right there. And now I'm going to multiply that by a -3, because there's my y, right? We're replacing that y with that -3. And then I'm going to say plus my x squared. I'm going to have a -1 squared. And I'm going to have my y squared becomes a -3 squared. All right. So if you take a look, I should be able to match up. Every single x should match up to a -1, and every single y should match up to a -3. And now that I've got this all written out, right, now I can begin the mathematics. All right, I don't have any parentheses that are like grouped together. I have my information about my exponents. Let's go ahead and get started on those. Again, our order of operations is going to dictate how that works. So I've got 1 times, well, cubed. I'm going to have a -3 times a -3. That's going to give me a +9. Times a -3 is going to get me a -27. And I'm going to put that in parentheses so we know that we're not actually subtracting it. That's 1 times that value. I'm going to have a -2 times a -1. So that's going to become a +2. And then I'm going to go times a -3. So we're going to do this in actually 2 passes now instead of 1. And then I'm going to say my -1 squared is going to give me a 1. And I'm multiplying that times -3 squared, which is going to be a 9. All right. So now I've got -27, right? When I do this multiplication, I get -27. Here I'm going to wind up with a -6, right? 2 times -3 is going to give me a -6. And then here I'm going to add 9, right? 1 times 9 is going to give me a 9. So at this point, it becomes addition and subtraction. This becomes a -33. And then when I add 9 to that, so -33 plus 9 is going to give me a -24. And there's my answer. All right, one more thing I want to go over. Translating words and from English into math is a challenging thing, and that's pretty normal that it's challenging. I want to walk through 1 or 2 of those and just kind of show what's happening. All right, so if I say for less than 1/2 of a number, well, when I say for less than could be this, or it could mean subtraction, and the context is going to make the difference. So I'm saying for less than 1/2 of a number. Well, that sounds like a subtraction to me. I'm not saying something is less than something else. I'm saying I'm subtracting it. It's less than, not is less than, if that makes sense. Hopefully it will here in just a moment. So I'm going to have my for less than minus 4 1/2 of a number. And I'm going to use n for my number. And now I've translated that from English into math. That's 4 less than 1/2 of a number. All right. When I have 12 times the sum of a number and 7, I've got 12 times, well, that's pretty straightforward, times the sum of, well, sum means add, and that means this 12 is operating on everything that's being added together. So it's the sum of n, or a number, plus 7. And now it's translated from English into math.